So there are two temperature scales that you're hopefully familiar with that have done exactly this. There is the Fahrenheit scale, which is used very commonly in the United States. There, Fahrenheit, a long time ago, said that he would say 0 degrees Fahrenheit was the coldest thing he could make by mixing salt water and ice. If you've ever made ice cream, you know that when you mix salt into ice, it melts the water and makes it all colder. The coldest he could get, he called 0 degrees Fahrenheit. And then he took a person's temperature, and he called that 96 degrees Fahrenheit. You'll notice that's not the same as what we consider a person's temperature today. He didn't measure it terribly accurately. And the reason he wanted 96 is that he could divide his thermometer up into 3 pieces, and then each one of them would have 32 degrees inside that third of his length. It's easy to split something into 32 pieces. You cut it in half, and then you cut it in half again, and several more times until it's 32, because 32 is 2 to the 5th. Now, somewhat later, they made the centigrade scale. Centigrade, centa means 100, and they said, let's make the freezing point of water our 0 point, and the boiling point of water at atmospheric pressure our hot point, and we'll call that 100 degrees. For doing math, 100 is much simpler than 96. It's not as easy to make the instrument, but by the time they did this, they were more skilled at making instruments. It turns out that the freezing point of water is not completely constant. It depends on how pure your water is. It depends on the pressure of the water. The same is true of the boiling point. So now we have a slightly modified version of the centigrade scale, known as the Celsius scale. For essentially all of our purposes, the Celsius scale is identical to the centigrade scale. You can still treat it as the freezing point of water being 0, the boiling point being 100. That actually sets the values for atmospheric pressure. We'll talk more about the exact calibration points of the Celsius scale later, but you should know that they are absolute 0 is said to be at 273.15, negative 273.15 degrees Celsius, and the triple point of water, where water can be a solid, a liquid, and a gas all at once, is set to 0.1 degrees Celsius. You'll notice these are not particularly simple numbers. The reason we chose these odd numbers was to match up with the centigrade scale as accurately as possible. It's important to be able to convert back and forth between Fahrenheit and Celsius temperatures. The formula is that the temperature in Fahrenheit is 9/5 the temperature in Celsius plus 32 degrees. The reason for that is that now Fahrenheit is defined to be boiling at 212, just like Celsius is boiling at 100, and freezing of Fahrenheit is 32, freezing of Celsius is 0. We have a few other temperatures here. For example, body temperature is about 37 degrees Celsius. It's about 98.6 degrees Fahrenheit. Comfortable room temperature is about 20 degrees Celsius or 68 degrees Fahrenheit. There are a number of other points here. For example, they coincide at negative 40 degrees. A word of warning, this formula with the plus 32 is only used if you're actually converting temperatures, not if you're converting temperature differences. If you're converting temperature differences, you don't need the plus 32. It's just delta T Fahrenheit is simply 9/5 delta T Celsius. So that's what we have written down here. A change in temperature of 5 Celsius degrees is equal to 9 Fahrenheit degrees. Notice there's a slight difference in terminology. We like to say degrees Celsius or degrees Fahrenheit if we are talking about the actual temperature. If we're talking about changes in temperature, we like to say Celsius degrees. So we change the order and we put the degrees after the unit. It's a minor difference, and if you get it wrong on a test, I'm not going to dock any points, but it is the convention.